Hi, what I thought we'd do today is build an electronic kit. So this is a kit that was provided to me by Banggood, and what it is this DIY electronic Aurora kit. So it's got a bunch of RGB LEDs that I think will fade in and out and make nice patterns, and as you know I quite like LED projects, so I thought this would be a nice one just to have a play with, and maybe have a look at soldering techniques and that kind of thing while we're doing this video. So what we'll do is we'll open up the bag and see what we've got inside. Right, so we've got a 3.5mm adapter. I'm not sure what we need that for. I don't think it's you know, sound to light or anything like that, but I might be wrong. And then we've got what looks like a piece of acrylic. The PCB, so we've got a USB connector, presumably just for power. Looks like a whole bunch of resistors on this side for controlling the current through the LEDs. All of the LED pads, so there's going to be quite a bit of soldering here, and then a few passives and a transistor or so just around the main micro, which is pre-mounted. So it looks like from here the smallest thing that we're going to have to assemble onto it is the SOT23 transistors. The rest are 0805s it looks like, so that shouldn't be too difficult. I think it's just going to take a bit of time to do all the soldering. And then we've got a whole bunch of RGB LEDs, so these are the 4-pin LEDs, so a common anode or cathode, and then 1 pin each for the RG and B channels. So this microcontroller is clearly controlling these LEDs directly. There's no special functions built into these LEDs, no microchip like the automatic colour changing ones. We do have a remote control, so we must be able to do some control functions remotely. And then we've got the remaining components, so a whole bunch of resistors, a few transistors, capacitor, and a few other bits and bobs. So one thing that's quite nice, you don't always see this with all of the kits on these websites, but it does actually provide a schematic and a few troubleshooting details. So we've got the schematic here, which we'll look at in a second. We've got some details on how to build the kit, and then they've also included some troubleshooting. So clearly some people have had problems with assembling this, and I'm not surprised really, because you know, if you get the LEDs in the wrong orientation, and I can't see any markers to say at the moment sort of which way around you put the LEDs, then obviously you could be assembling the whole thing wrong or just have the odd LED incorrect. So that's nice that they've done that. They also included a few data sheets for some of the components that they've used. So this kit's built around the STM8, which is a fairly simple microcontroller, nothing special really, running at 16 megahertz, just a standard 8-bit micro. What it does have is multiple PWM channels. So I haven't actually looked at the schematic yet, but what I'm assuming is really that we've got the RGB channels controlled, and then we're multiplexing all of the LEDs. So I'll just tidy up a little bit and then we'll have a closer look at this schematic. Right, so what we've got is fairly straightforward. We've got this microcontroller here providing 3 PWM channels, and those 3 PWM channels are driving these power FETs directly, and then these FETs provide the cathode connection to all of the RGB LEDs on the PCB. And then the LEDs are multiplexed into groups of 9. So you can see the sort of 9 common anodes here, which are driven by these 9 power transistors. So these are just bipolar transistors on this side. So we don't have full individual control of every LED on the PCB. What we've got is 9 concentric rings of LEDs. So sort of 1, 2, 3, 4, 5, 6, 7, 8, 9. And that will give sort of patterns of RGB, you know, around the PCB, spreading out towards the outer circumference. So nothing too complicated. It's just going to give a nice visual effect, hopefully. And then in terms of other components, there's really not much on here. So we've got the mini USB connection for the 5-volt supply, and you'll notice there's no voltage regulator or anything. This provides the VCC to the microcontroller and the LEDs directly. And then there's just the two capacitors, one bulk capacitor, 10 microfarads, and presumably 100 nanofarads or something like that. So not a great deal going on there in terms of voltage regulation. We've got an infrared receiver, so this is your standard 38 kilohertz or 36, whatever it is, receiver. So this has all the magic in it, really. You just have to decode the data stream. So this has just got the 5-volt input, ground, and then the data coming out, which is being read by the microcontroller. And then we have what appears to be a programming header as well, so a 4-pin programming header with the two actual programming pins here. And then there's not really much else going on. It doesn't look like it's using an external crystal or anything, so it's just using the internal oscillator. And then we've just got a single resistor current limiting for each LED. So I've just opened the bag with the components. So we've got a few bits of hardware here. That's just to mount the PCB onto the acrylic circle, just to provide it with some rigidity. We've got some posts here and some screws and some nuts, so that's to hold that together. That's fairly self-explanatory. We've got this USB cable, which is quite curious. So one thing that I missed on the schematic was actually, we've got our 5-volt supply and our ground into the mini USB, but we've also got this capacitively coupled signal which goes to one of the pins on the microcontroller. And what we've actually got here is a USB cable where we've got a mini USB connector on this end, and then at this end we've got a USB connector, USB-A, and then a 3.5mm connector. So it clearly must have some audio synchronization functionality, and they have capacitively coupled, so you wouldn't be able to blow up your microcontroller by plugging in an incorrect USB lead. So it's basically telling us to start with the 10K resistors. So I've got the Metcal iron turned on. So starting with the 10K, then the 1K is all around here, and then the 150 ohms. So it's fairly self-explanatory actually. They must have written this after having some trouble. So we'll get started with the assembly. So the best way to go about soldering these 0805 components is to put a bit of solder on just one of the pads for each component, and then once you've done that you can place the part, heat up that one pad with a bit of solder to affix the resistor or capacitor in place, and then once you've done all that you can then solder the other pad. So I'll start by just putting a blob of solder on each of these. And just to assist with the fume extraction, I've got a fan here, which I'm just going to turn up slightly, which is just blowing a breeze across the PCB. I tend to find the extractors are quite useless really. You have to have the extractor right up against the board, and it makes loads of noise, whereas I just tend to have the windows open a little bit and a fan just gently blowing across, and it just gets it away from your face. So there's just the four 10K resistors, and you can see I've just put the resistors on with one piece of solder there, and what we'll do now is just solder the other sides of those resistors. And we don't seem to be having any trouble here with getting the solder to flow. You could use a Flux pen if you needed to, if you're having a little bit of trouble, but this PCB seems fine. It's been tinned, so we're having no problem here with the solder flowing. So for the SOT23s, what I tend to do is a similar method really, is just put a blob of solder on the single pin at the top, and then you place the part in the same way that we did these, and then just solder up the other two pads. And for a right-handed person like me, I always orientate the PCB so that the pad that you're trying to solder is on the right-hand side, so you can come in like this with the soldering iron and not be working, you know, across the PCB. Right, so here's where I could see things going wrong for people. What they're suggesting you do is prepare the LEDs first by trimming them off here, and then looking through the LED to see where the cup is for the common connection. So you can see on the LED here, we've got the cup here, which houses the 3 LED dies, and then we've got the other 3 legs here, which just have the bond wires, which you can't see in the Milky package, which is why this is a little bit sketchy. You can't see that very well, but there's 3 bond wires going onto each of the dies that are in this cup. So we'll follow the instructions. There is a marker here where the flat is, but I have known from some suppliers when buying them cheap from the Far East, this marker to be you know, incorrect. Sometimes it's the anode, sometimes the cathode, and even within you know, a batch of LEDs, they've been incorrect. So what we'll do is we'll trim them all off, and this is where the takeaway container thing is useful, because you can just have your LED and chop with the cutters, and you know, the bits don't go flying everywhere. So I'm going to prepare all of these LEDs now, and then we'll try and solder them in. Right, so that's the LEDs trimmed. That took about 10, maybe 15 minutes to do, and halfway through I was thinking, is that really the best way of assembling this? But it turns out that on the legs, the slightly wider area here won't fit through these pads, because these LEDs have quite a close spacing for through-hole parts, which means that they've had to use really small holes and small pads. So if you push the LED into the PCB, let's see if I can get it in, it won't actually go past this point here. So I can see why they've recommended that you trim them first. So what they're saying is, if you look at the LED and where the common is, which is where the cup is, that is the one with the longest lead. It's also the one with the flat edge on the LED here. That wants to go closest to where, it says in the paperwork where the square pad is, but they've obviously changed the PCB because these are all the same pads, but there is a tiny little marker there which says which way round. So the next job is to put all the LEDs in, and then we'll flip it over and solder all of the LEDs in place. And there we go. So we've got about 1, 2, 3, 4, 6, 7 LEDs spare. My guess would be that they weigh these LEDs and put them in a bag, so they just allow a bit of tolerance on top of that. So what I'm going to do now is I'm going to just quickly inspect these with the magnifying glass and just make sure that they're all facing the correct way. And then what we're going to do is flip it over, and we're going to solder all the LEDs in. Right, so I've inspected the LEDs and they all appear to be the correct way around. So what we need to do is flip it over in order to solder it. What you could do is place a piece of card or something similar on top of the board and then flip it over, and then you'll be able to solder all of the LEDs. I think I'm going to cheat. So I bought a PCB assembly frame quite a while ago that should clamp the LEDs. It's got a foam backing that presses against them, and then you can flip the board over and solder all of the solder joints. So I'm going to try and rig that up. I've never actually used it, I bought it when it was in the sale. I think Farnell were clearing it out, so let's give it a go. Right, so we need to attempt to clamp this in place without dropping all of the LEDs out. So let's see if I can lift up the PCB. It's still got a bit of blue tack on the bottom. And then we've got this, this layer on here which clamps over the frame, and the idea is this foam should press against the LEDs and hold them all in place, allowing us to flip the PCB over. So let's see if this works. That all feels fairly secure, so hopefully, a leap of faith here, all the LEDs don't drop out. We have got one that's dropped, but there we go. So now we can solder all of these. Oh, I see. There's a ridge in the foam, so all of the centre ones are not quite in the right place. So we'll have to deal with those afterwards. But that looks pretty good. Yeah, we just need to make sure we don't solder any of the LEDs in this line. So I'm just going to get there's a little attachment which allows you to angle this up nicely so you can work on it quite easily. So I'm just going to get all that hooked up next. Right, so I've just switched out the soldering iron for the ultra-fine pencil because these pads are very, very small, and I think with the other soldering iron we would potentially bridge across some of these contacts. So we should be able to whiz around all of these pretty rapidly, so let's see how we get on. Right, so that's all of the LEDs soldered in. It took about 25 minutes to get those done. Next, we've got to do all of the 150 ohm resistors on this side of the PCB. I also noticed I did miss off a couple of capacitors. That was step 2 and 3, which I glossed over because they'd already soldered some of them in. So I assumed they'd done all the steps up to that stage. But yeah, so next is this big array of 150 ohm resistors, which might take a while. So let's get started on that. So we'll do it the same way as before, where just put one blob of solder per component, ready to tack down each of those resistors. And this is where having a really good soldering iron really helps things, because we can just blast through these really quick. So this soldering iron is slightly different to the one that I did in one of my very early videos. So I managed to get a MX-500, one of the new style ones, off eBay about a year ago now, at a bargain price. I think I only paid about 120 or 130 pound for the base unit, and then the ultra fine soldering iron. So this one's got a lower wattage capability. It's physically quite a lot smaller. If you compare it to the original iron, you can see there's quite a bit of difference, but it's really good for surface mount soldering. The MX-500 I think is only rated to about 40 watts, whereas the MX-5200, which is my main soldering iron, you can dump 80 watts, but for this kind of thing it's absolutely fine. And as you can see, it heats those pads no problem. We can just fly around. And as I mentioned earlier in the video, just to stop the smoke from the solder blowing in my face, I've just got a fan just lightly blowing across the PCB. It is nice and quiet that way because you can just use a little standard PC fan. And actually what this one is it is actually a fume extractor, one of those fairly cheap ones that had a charcoal filter in front of the fan, but in its standard configuration where it would try and extract the fumes away from you, you'd have to have the fan screaming away, and it really didn't really do much. I've just flipped the fan around, put a speed controller in, so we've got a ball bearing fan, which is one of these really powerful ones that can, if you turn it up to maximum, it's pretty loud. It's like one of the ones out of a server, I think, but that seems to do the job nicely. I think the PWM controller was just a cheapo thing off, I think it was actually from Banggood, which I ordered. So here you can see I've just emptied out some of the resistors, and then if you got one loose here like this one that's the long way around, if you give it a little tap, you can flip it over. That's a lot easier than trying to do it on the tabletop. Right, so that's the 150 ohm resistors all soldered down. I think there was about 170 of those, something like that. That took about 15 or 20 minutes, but we're on the final straight now. We've just got a few capacitors which I missed off at the start, and then the infrared receiver. So we'll start with these capacitors labelled 104. That should be 100 nanofarads, but the little strip here with 3 capacitors says 104. So I'll just get these out of their packaging. And just to verify, we can use the peak LCR meter with the special probes. And there we go, yeah, basically 100 nanofarads. And these 10 microfarad capacitors in ceramic are pretty hard to come by at the moment with the global capacitor shortage. So we've just got a couple of components left. We've got the infrared receiver, and then we've got this 470 microfarad capacitor, which isn't labelled up or anything anywhere. There's no place for it. We'll just bend these legs. Get a nice right angle. And just solder this in. So I don't think it mentions the use of the 4-pin header, so that might be a good place to put the large capacitor. So we should be safe just to solder that in there, like that. So let's solder that in. So I guess our next thing is to test it. So I won't put the plastic on just yet. I'll just prepare the USB cable. So I guess we can do one of 3 things really. We can either plug this in and watch it blow up, plug it in and find that I've got all of the LEDs the wrong way round, or it's going to work. So I think we're just going to go for it and plug this straight into a USB port, and let's see what happens. Right, so I'll just dim down the lab lights a little bit. And we've got a little USB hub here. So here we go. Alright, so we've got a few failures. So that's possibly, there's a whole ring out, which is possibly one of the transistors. But we've got a couple out here. And there's no obvious solder bridges or anything. The resistors are in place. Aha. Okay. Right, failure on my part. Follow the instructions, because I can't remember if I mentioned it in the video that sometimes these LEDs can't be relied upon to have the flat side. So these ones are correct, but yes, these LEDs can't be relied upon to have the flat side as a cathode or anode marker, because I'm not sure. Yeah, so the flat. Let's see if I can zoom in. This is one of the ones that's not working, and you can quite clearly see we've got the flat edge just here, same as this one on this side. But if we look side on, so this is one that's working, and you can see the cup for the LED is on that 3rd pin, and that's the one closest to the middle, which is how it should be. If we look at the one that's not working, the cup for the LED is on the 2nd pin, even though the flat's on this side. So there we go. I need to correct some of those. There did appear to be a complete ring out though, so I'll double check those ones. But yeah, just looking now, I can see a couple there. That one's definitely the wrong way around, and that one is. So yeah, it's really annoying. So the instructions are correct. Go based on what it says through the go for the visual indicator of actually where the LED is rather than anything else, because these are incorrect. Right, so just while these LEDs are out, the ones that are the wrong way round, I've just had a look, and there is definitely a complete ring of LEDs not working, and they are all the correct way, well, most of them are the correct way round, so they should do something. So it looks like either there's a short circuit or one of the transistors that drives that row is not working, because I think the only way you could have it not working is if there's a short between this common and ground, or if one of these transistors isn't working properly. So I'm just going to try and track that down. That ring correlates to Q7, so what I'm just going to do is maybe tidy up around that transistor just in case we've got a bad solder joint. Okay, that seems to have fixed it, so we've just got a couple more the wrong way round, so I can take those out now. Right, so I think I've got them all in the right way round. They're not soldered in yet, so this is the other method I was thinking about for using to hold the LEDs in place, is to flip it over like this. Right, so I think that's all of the LEDs corrected. Definitely those ones that I took out were the wrong way round, so they had the flat mark on the wrong side, and I should have trusted my instinct there, really. I've been burnt by that before. It could have been a lot worse, it could have been all of them, so fortunately there were significantly less that weren't working, so that was a fairly simple fix. Although I would say these are plated through-hole PCBs, so if you don't have a desolder gun, you're really going to struggle getting these out and clearing out the holes. So follow the instructions and do it the right way. But let's see if it works now. Yeah, there we go. Let's dim down the lab lights a bit. Yeah, it's quite nice actually. It looks a little bit flickery on camera, but I'm not seeing that by eye. We have still got the remote control as well, which we need to try. So if we press power, see, I see a little flicker, but it's not doing anything. Menu, nothing. It's definitely doing something. When I press the button, it's receiving it, because there's a slight shimmer when you press it. So number 1 does something. I wonder if that's the sound to light. Yeah, it's the sound to light. If I short out the audio connector, you can see it's just picking up noise when I've not got it and I'm connecting it to 0 volts, and that seems to take it down to 0. So it's kind of a shame it doesn't have a microphone built in, because I'm not going to plug this into any of my audio equipment. Number 2, that looks exactly the same as 0. Yeah, that's exactly the same pattern. 3. Okay, yeah, so we've got some different patterns on 3. Yeah, so I think it's only got 3 patterns, because these buttons definitely aren't doing anything again. And it is still receiving the signal, because I can change it through these 3. But yeah, but only buttons 1, 2 and 3 seem to change the mode. But there we go, that's pretty nice. I'll just put the casework on it, and then I think we'll call it a day. Right, so there we go. I've put the acrylic cover on the back. I'm assuming it's there to stop you shorting out the PCB if you place it down on your desk or on some conductive surface or something. It wouldn't really make sense to cover up the front, because you're going to just see sort of the dirt and dust that's going to collect on this acrylic, which it always does. The only thing is that it sort of obscures the USB port, so yeah, you're not going to be able to take that out, so that'll have to stay in there. But there we go. So that was quite a fun kit. There's quite a lot of soldering involved. It probably took me about between an hour and a half in total to assemble this and to troubleshoot it. But yeah, if you haven't got the greatest skills or the greatest equipment, it's going to take quite a bit longer, and you might want to do it in stages, sort of attack the LEDs one day and the other stuff the other day, and just take your time over it, because the potential for error is quite high, and then I think once you have made a mistake with the LEDs, you're really going to struggle to get some of these out. But there we go. So I hope you enjoyed that video. Hopefully you learnt a little bit from the soldering as well. But there we go. Until next time, thanks for watching.